What is next-generation sequencing?
So NGS is a really important piece of the leukemia workup and diagnostics. NGS stands for Next Generation Sequencing, which is probably not the greatest term because eventually we'll come up with something better than next generation. So I'm not sure what we'll call the next iteration. So the most important part of NGS is that you have to know what you're looking for. So you have to design the panel so that you're going to sequence the portions of the genome that you're interested in. In leukemia, this matters a lot. So for example, there is a gene called CEBPA. CEBPA is a transcription factor that helps white blood cells know how to turn on the proper genes in order to differentiate into a mature cell. If you have 2 mutations in CEBPA, that disease itself, that biallelic 2-copy CEBPA mutant leukemia, is exquisitely sensitive to chemotherapy. So it's actually very positive in terms of its overall prognosis. Whereas there's many genes that we know are more difficult to treat. For many different types of cancer, a mutation in a gene called TP53, which is a checkpoint protein that helps to identify regions of DNA mutations and halt that cell from undergoing cell division, is mutated in leukemia, and that's a really difficult to treat leukemia. And for leukemia, we've gotten kind of nuanced in this. So we've found that if you have a mutation in a gene called nucleophosmin-1, NPM1, but you don't have a mutation in a gene called FLT3, which is one of those oncogenes that I spoke about, that's a relatively favorable leukemia too. So it's not only what mutations do you have, but it's also what mutations don't you have that helps us pick the right type of therapy. Now, where we're going with this is trying to identify specific genes and specific pathways that we can actually therapeutically intervene upon. And this is important for 2 genes, one called IDH1 and one called IDH2. It stands for isocitrate dehydrogenase. This is an enzyme that's really important in every single cell for its metabolism and generating energy. And what happens when one of these genes is mutated is it no longer is efficiently making the energy that's necessary for that cell, but in fact makes an abnormal chemical we call an oncometabolite. That oncometabolite looks sort of like the energy source, so it binds to things where that energy source would normally go, but instead it blocks its activity. And so what we found is that we can actually inhibit the mutant forms of these IDH proteins. And in doing so, we've prolonged the lives of patients who have IDH mutant leukemia after they've failed chemotherapy. We're now starting to use these in earlier and earlier regimens for patients who have this particular type of mutation. But it's really giving us a new arsenal of tools in our toolbox to give to patients who desperately need it.